This next problem of ours is a very important and a very interesting problem. We are given that let C be a circle having center root 2 comma 0, and we need to prove that at most two rational points can be present on C. Now for proving that at most two rational points are there, we'll use a contradiction approach. First of all, let us assume the equation of circle as x minus root 2 whole square plus y square is equal to r square. Now let us say the general rational point lying on this circle is h comma k. So h minus root 2 whole square plus k square will be equal to r square. This is our first equation. Or we can simplify this equation further to have h square minus 2 root 2 h plus 2 plus k square is equals to r square, to have h square plus k square minus 2 root 2 h is equal to r square minus 2. Let us call it lambda. This is our first equation. Now we take case 1. This r square minus 2, which is equal to lambda, it can be rational or irrational. Let us take the case lambda equals rational. If lambda is rational and we have assumed that h comma k are rational points, so this is irrational. So comparing the rational and irrational part from the left hand side and the right hand side, we get s square plus k square equals lambda, and 2 root 2 h is equal to 0, so h equals to 0. H equals to 0 give k equals plus minus root lambda. So very clearly we can see that if lambda is rational and lambda is a perfect square, we get two rational points as, if lambda is a perfect square, then we'll get two rational points which will be equal to 0 comma root lambda and 0 comma minus of root lambda. Hence there are at max of two rational points in this case. We'll take the other case, which is, let's say lambda is not a perfect square. If lambda is not a perfect square, then very obviously this is irrational point, and hence no rational points from this case. So from case 1 we have got two rational points which are 0 comma root lambda and 0 comma minus root lambda when lambda is a perfect square. Now case 2 is lambda is equal to irrational. We had h square minus 2 root 2 h plus k square equals lambda. Now if lambda is irrational, equating the rational and irrational part, we get h square plus k square equals 0, which gives h is equal to k is equal to 0, and minus 2 root 2 h is equal to lambda. Since h is equal to 0, lambda is also equal to 0, which contradicts our given case, because we have taken lambda is equal to irrational and we are getting lambda equals 0, which is rational. So this case is also rejected. Hence from case 2 we are getting no rational points, and from the first case we are getting two rational points, 0 comma root lambda and 0 comma minus root lambda, in the case when lambda is a perfect square. Hence this proves that there are at max of two rational points present on the circle having center root 2 comma 0, and this is our final answer.